Your homework for tonight and the next 2 days is to develop some skills that you'll need to be successful at the Predator Prey project. First off, you're going to need to have a good understanding of Euler's method and the idea of a recursive formula for approximating values of a function given some initial value and the derivative of that function. For example, your homework sheet asks you to use an Excel spreadsheet to complete a problem here where y of x is a solution to an initial value problem. You have y prime and you have an initial value, y at 0 is 0. Then you're going to use Euler's method to estimate y at 1 and y at 2. So what is Euler's method? Euler's method is nothing other than repeated linear approximations. Begin with the derivative dy dx of your function. The derivative is itself a function that depends on perhaps x and y. You have an initial point x naught, y naught, and an increment delta x. The first thing you're going to do is move over to a new x point, delta x, away from your initial x value. To estimate the value of your function at that point, we use a tangent line approximation. y1 is your estimate of the value of y at the point x1. y1 is given by y naught plus the slope, the derivative of your function at the point x naught, y naught, multiplied by delta x. Don't forget to multiply by delta x. That tells you, taking the slope multiplied by delta x tells you delta y, how much your y value has increased. This gives us a new point x1, y1. We can then repeat this process to advance as many steps as we would like. y2 equals y1 plus the slope at your point x1, y1 times delta x. y3 equals y2 plus the slope at x2, y2, again times delta x. This is all interesting enough in theory, but it's a pain to put into practice unless you have some method of calculating these things very quickly. Fortunately, we do with Excel. Open an Excel spreadsheet here, and we'll begin. A column for x, a column for y. Let's let y prime be something other than your homework, so I'm not doing your homework completely for you. Y prime equals x plus y. This cell here, F3, is not calculating anything. It's just for reference. Delta x, we'll let it be 0.1. Then we'll put in initial values. I don't like 0 and 0. That's a little boring. We could put in 0 and the initial y value is 1. Remember, these are initial value problems, so you could be starting with whatever initial values you might be given. Our new x value is going to be our old x value plus delta x. We put that in, and we go to this little square we attempt to paste down. Nothing happens. It stays the same. It's because we forgot to fix the x value, the delta x. We want it to go only to that cell G4 and not to move down as we paste down. To do that, we're going to put a dollar sign on the 4. If we were pasting side to side, we'd also need to put a dollar sign on the G. Put a dollar sign on that 4. Now when we drag down, we're incrementing every single step by delta x. We want to do the same thing with y's, except our y's are going to be the original y value plus y prime at the original y value. Well, y prime is just x plus y, so it would be the original x plus the original y, and then we've got to remember to multiply using just the asterisks above your 8, multiply by delta x. And we'd better remember to fix that again or else it won't work. We're going to fix exactly that same cell for delta x, and now we can drag down again as far as we like. We notice that this function initially grows very slowly, but as y gets larger, the derivative, x plus y, is going to get larger too. We're going to get something like exponential growth. If you're not content with the number of cells you see here, we could certainly drag down quite a bit more. And you see it starts growing very, very quickly. Y of 7, when x equals 7, y of 7 is 1,571. That gets pretty large pretty quickly. If I want to see what this looks like now, and you certainly will for your project, we can take these values and put them into some kind of scatter plot. You could use just the points in a line. I kind of just like using a line for this. There you go. We have x and y. We can certainly edit the titles. We can do whatever we want with these. There's the chart title is just y. If we don't like that, we could certainly change that. Put in. I just took it out. Put it back in. What should we call it? I don't know. And we click out of that. We put in a horizontal axis title. We'll call this X values. In your Predator project, obviously be something different. We can then edit our legend. We can edit our vertical axis. We could certainly change colors, axis size, grid lines, make our chart larger. The interesting point here is simply that we've modeled something that looks like exponential growth. Moving back to your assignment, this looks exactly like what we just did. We used delta x, 0.1 instead of 0.2, but we estimated in this case y at 7, also did y at 1, y at 2. Moving down here, you'll see a case where we could potentially have a problem if y ever got to 0. And in fact it could, depending on where you're going to go with your step size. Dy dx is negative initially, y of 0 is positive 1. You may well get to a problem point. In part C it says look at the graphs and notice if anything strange happens. Y of x here in the next one, this is just a more complicated curve. Use Euler's method with different step sizes. And then finally in 4, you're just going to look at what happens not in terms of the step sizes, but in terms of the accuracy that you need. And you'll see that in order to get more accuracy, you're simply going to have to make your steps sufficiently small.